Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is December 17, 2023, and the time is around 4:12 p.m. Okay, my topic for this session will be a continuation of my trigonometry long video format topic, and we are now on lesson number 43. Lesson number 43 will be an application problem involving double angles. Okay, so let us try to study or discuss for this morning the importance of the knowledge of identities and the solution of actual problems in real life. Okay, let's proceed. The title of the subject matter for this morning will be trigonometry, and we are now on lesson number 43, and we are running smooth. We are almost done with trigonometry. I think 85% or 80%, except for the sine law and cosine law that involves the solution of oblique triangles. Okay, the title of the topic for this morning will be trigonometry lesson number 43. Okay, on the actual topic problem on double angle, meaning it will be the application problem of a double angle identity, which was derived from the previous lessons. Okay, I will not try to show at what I call this, write the problem on the board. I will just give the figure, then I will try to discuss how the figure will be coming out. Okay, the example will be this. We are given a figure here. So instead of writing the verbal problem here, I will just give you the figure. Then I will try to discuss, and I will give the specs of the problem and what is being asked for the given problem. And here we are given a horizontal ground. Horizontal ground meaning the angle of the ground is at a perfect level, meaning the angle of the ground is at 0 degree. And from this ground, we got a high-rise building in which the height is unknown. Actually, what is being asked here is the height of the building, height, from the ground to this top portion, point A here. Okay, the condition is this. We got the surveyor, maybe the initial location of the surveyor is actually at point A, right? So if he got a transit, then he will try to look upward for the angle of elevation of this point A here, the corner of the building here, the top portion here. So by using what you call this a transit, he will try to measure the angle of elevation of this point A here with respect to point A. And he found out that the angle of elevation, okay, it's not yet given. He just found out a certain value designated by an angle theta. Okay, so at this location point A here, if he tries to take the angle of elevation of point A here, the topmost portion of the building, the angle is angle theta. Then if he moves forward to the right, going to the base of the building, 60 feet, he moved forward 60 feet. So he changed location, and he is now at the location point B. Again, by using his transit, he will try to look for this point A here. Okay, he will try to take the angle of elevation with respect to point B. And he observed that the angle of elevation was twice the original angle. So if the original angle at point A is theta, at point B it is twice theta. Okay? Then again, he moves forward to the base of the building 25 feet further. This is 25 feet. So he is now at the location point C. Right? Then again, by using his transit, he tried to take the angle of elevation of this point here, this point. Because we are interested on the height of the building, right? And what comes out is this: the angle of elevation at location point C is the complement of the angle at point A. Complement, meaning the sum of this angle here plus this angle is actually 90 degrees for them to be complement. So if he says that the angle measured here is the complement of theta, this angle here should be 90 degrees minus theta. Okay? What he got here, a reading will be 90 degrees minus theta. It is the complement of the angle of elevation at point A. So if this is 90 degrees minus theta, and this is a right angle, this portion here should also be theta. Okay? That is very important because in the so-called formulation of the equation and how to compute for the unknown, we must have to bring out three right triangles. Okay, trigonometry is always a solution of a right triangle. That's why it's a must that we should know the so-called definition of the different trigonometric functions. So it depends on the condition of the problem. It's up to you to use a certain identity which coincides with the solution of the given problem. Okay, let's try to bring out the unknown. So what is being asked here is height h, the height of the building. Okay, so we are given three intermediate points A, B, and C. He measured the angles. At point A, it is theta. At point B, it is twice theta. At point C, it is 90 degrees minus theta. The problem is asking what will be the height of the building. Okay, let's try to bring out the solution. To bring out the solution, we must have a representation because there will be unknowns, right? For the meantime, the height of the building is unknown. It's designated by capital letter H. And the location of point C with respect to the base of the building. Okay? This is the ground, this is the building, and supposed to be they are perpendicular with respect to each other. So this angle here is actually 90 degrees. And for the meantime, we do not know the distance of point C from the base of the building. So we just represent that by simply x. Okay? So actually the unknown here is actually h and h. So we got two unknowns. We must have to bring out two equations involving two unknowns. Then we solve it simultaneously so we could compute for h. So we are actually interested in the value of x. And as soon as we compute for the value of x rather, we could compute for h. Okay, let's try to bring out the solution. H will be the height of the building. X will be the distance of point C from the base of the building. This is x. Okay, let's try to bring out the solution. Let's try to bring out the biggest right triangle. The biggest right triangle will be from A to D and from D to E. It is this. Right? This is point A, this is point E, and this is point D. Right? The total length of distance AD will be this total distance here. It will be 60 plus 25 plus x. Okay, so that will be 85 plus x. This 85 is actually 60 plus 25. Right? And the adjacent side, opposite side, considering theta, is the unknown height of the building. So we bring out this side here and this side, considering the first angle theta, it is this. Right? Okay, I will try to erase this one so it looks good. Okay. So in here, we are given a right triangle that contains the unknown height and the distance x. Okay, let's try to bring out the next right triangle. Again, the one containing angle theta, this one here. This angle here is 90 degrees minus theta, and this is theta. I will try to invert it a little bit. So this will now be theta, and this portion here is actually 90 degrees minus theta. Okay? It is this angle here which we are considering for the meantime. It's not the 90 degrees minus theta, it is. So considering theta, the opposite side is x, and the adjacent side is the height. Okay? The opposite side is h, and the adjacent side is x. Is it correct? Oh, the adjacent, they should be, sorry for this one. They should be x, and this is h. Right. Okay? Because this is actually point E. Point E. Okay? The other one is, this is point C. And this is point E. Okay? So we brought out two right triangles already. And in here, there is again an angle theta, x, and h. So actually, from the first right triangle, we could bring out a relation. Again, by using the second right triangle, we could get another relation. So using the first right triangle here, this one here, if we try to take the tangent of this, it will be h over 85 plus x. That will be equation number 1. Okay? You see, guys, how we formulate our equations by using the definition of the different functions. For the meantime, it is tangent. Taking the tangent of this, it will be x over h. Okay? And that will be equation number 2. Okay? There is an h here, there is an x, there is an x here, there is an h. Okay? So to take the relationship of h rather, as a function of x, we equate equation number 1 and number 2. Equation number 1 and number 2, tangent theta, this tangent theta are the same, so we could equate it. So tangent of theta for the first one will be h over 85 plus x equal to x over h. Simplifying, cross multiplying, h times h will be h squared. The right hand side will be the product of x times the quantity. Oh, I now rearrange this one. It will be 85 plus x, or x plus 85 is the same. So h squared will be the quantity product of x times quantity x plus 85 plus quantity, and this will be equation number 3. Later on, we will be using this relation here. So we take note of this one. That's why we call it equation number 3. To take the other relation, because there are two unknowns here, right? So we must have to bring out another equation involving x and h. Then we'll solve it simultaneously. And that's algebra already. So this trigonometry will now be a combination of trigo concepts and algebra concepts. By using the identity, double angle, that's why our topic for tonight is double angle. Okay? Tangent of 2 theta will be 2 tangent of theta over 1 minus tangent square of theta. We derived this one the last time around. I just presented this one as alpha, but you could place any angle you want, right? So if you use theta on the left hand side, theta will also be the angle on the right hand side. So by using this identity here, double angle, that's why the topic for tonight is example problem and double angle. Okay? Tangent of theta, 2 theta will be 2 tangent over 1 minus tangent square of theta. This theta here we are mentioning is actually this one here. Okay? No, it's not this one. It should be this one. Right? The tangent of 2 theta, this is twice theta. Let's try to bring out the third right triangle that comes out from the figure. Considering this twice theta here, from point B to D and E. If we try to bring out this total distance will be x plus 25. and the adjacent, the opposite side will be h. So we could bring out a relation by using the definition of tangent from this right triangle. So if we try to take the tangent of 2 theta, it will be h over x plus 25. So tangent of theta, we follow this, but we will substitute the value of tangent of 2 theta emanating from this. So it should be h over x plus 25 equal to twice, right? Twice tangent of theta. But there are two values of tangent of theta. We will use the simpler one. We will use this one. Actually, we can use this one. It's the same. But for the solution to be simpler, we use this one. So this should be twice tangent of theta will be x over h over 1 minus the quantity x over h quantity squared. Okay? So this is now pure algebra. So we got another equation involving x and h. So simplifying further this one, we will rewrite the given left hand side. It is x over 25 plus x equal to, okay, this one here, that will be 2x over h, right? So it is this. And the simplification of the numerator, okay, we will multiply 1 by h squared, so it will become h squared minus x squared all over the common denominator h squared now. But if we try to change the operation from division to multiplication, we will take the reciprocal of this. So h squared will be up all over h squared minus x squared. Okay? Actually, we can transfer this h now. We place it in the left hand side, so this will now become h squared. We could do that. It's the operation is multiplication. This will be over 1. So as soon as we transfer this h here, actually we could cancel h squared and h squared now. Right? We cancel it. So it will become, this will now be 1. 1 times this will be h squared minus x squared. And for the right hand side, it will be 2x times the quantity x plus 25. And that will be equation number 4. Okay? So to solve this problem, we must have to use equation number 3. We will replace h squared by the value, okay, x times the quantity x plus 85. Okay? So by using this equation here, we place this value of h squared back here. So the only unknown now will be x. Okay, substituting. H squared from equation number 3 will be x squared plus 85x. Okay, it is the product of this. Okay, minus x squared equal to, we expand this one now. This will be 2x squared plus 50x. Am I still on camera? Okay. For the left hand side, it's we are on the lucky side. This x squared here, cancel with this. So what remains on the left hand side will be 85x. And we transpose this one in the right, then we try to rearrange, so it will become 2x squared plus 50x. We transpose this to the right, right? Then we rearrange. This is minus 85x, and this should be equal to 0. It's again algebra. Try to maintain the unknown variable on the left hand side on all possible constant. If we do not need it on the left, we put it on the right. Okay, simplifying further, we combine similar term. 2x squared, 50 minus 85 will be negative 35x, and this should be equal to 0. I want to eliminate the coefficient 2 here, so I will try to multiply this by 1/2. So 2x squared times 1/2, it will just be simply x squared. Minus 25x times 1/2 will be 17.5 times x. And this should be equal to 0. The resulting equation is actually a quadratic equation. Okay? We factor out x times the quantity x minus 17.5 plus quantity, and this should be equal to 0. Then as a rule in algebra, we equate each factor to 0. So x will be equal to 0, okay? x1 will be equal to 0. and we disregard this one. Okay? Taking the next factor, we equate that to 0. X minus 17.5 equal to 0. So x now will be equal to 17.5. So the correct value of x, which will satisfy for this to be theta, twice theta, and this is 90 degrees minus theta, is x is equal to 17.5 feet. So by going back to this equation here, okay, we will solve for h. So we'll remove the 2, then we'll place a square root here. Right? So this h now will be 17.5, okay, times the quantity 17.5 plus 85 plus quantity. If you try to take the simplification of the inside, then you try to take the square root, the value of h will be 42.35 feet. So that will be our answer. Okay, that's it, guys. That's how we solve a real problem in real life by using our knowledge of the so-called identities, and for the meantime, it's a double angle. Okay, that's it. Good morning from Los Angeles. This is Professor David Jenner.